Hello, in this video, we will be discussing multiplication of matrices. In order to perform the multiplication operation of two matrices, you need to take note of three important rules. You may pause this video to go through the three important rules. In order for you to understand better, we will explain these three important rules with the use of an example. The example says if matrix A and matrix B are given as follows. First question, calculate AB. Second question, calculate BA. Solution. Calculating AB. AB means A multiplied by B, or it means A point B, which is something as A multiplied by B. So when we are multiplying two matrices, the first thing we need to determine which matrix is the first one, which matrix is the second one. So depending on the question, that's how you're going to be able to determine that. So according to this question, the first matrix is A, and the second matrix is B. So having determined the first matrix and the second matrix, the order in which the question is asked determines which matrix is the first and which matrix is the second. Why is this important? This is important because if you look at the rule 1 states the number of columns of the first matrix must be the same as the number of rows of the second matrix. If rule 1 does not hold, then a multiplication operation cannot be performed. However, if the rule 1 holds, then we can perform the multiplication operation. So the first matrix, we can determine that the size of this first matrix is, go to the matrix A, we can see that we have row 1, row 2, that is 2 rows, and we have column 1, column 2, and column 3. We have 3 columns. So the size of matrix A is 2 rows, 3 columns. Hence, we say the size is 2 by 3. For matrix B has row 1, row 2, and row 3. So 3 rows, and it has column 1, column 2, 2 columns. So we can say that the size of matrix B is 3 rows by 2 columns. So 3 by 2. Now, rule 1 states that in order to perform the multiplication operation, the number of columns of the first matrix, the number of columns here is 3 in this first matrix here, must be the same as the number of rows in the second matrix. The second matrix, which is B, has 3 rows. So since we have 3 columns in the first matrix and we have 3 rows in the second matrix, then we can perform the multiplication operation. However, if these two values here were not the same, then we can't perform a multiplication operation. So that explains rule 1. As for rule 2, we will show that while we're doing the multiplication operation. Let's jump to rule 3. We'll come back to rule 2 later. As for rule 3 says the product matrix, that is the answer that we get after we've done the multiplication of the two matrices, the answer must have a size of number of rows of the first matrix and the number of columns of the second matrix. So which means the number of rows of the first matrix is 2 and the number of columns of the second matrix is 2, which means we expect that the answer, that is when we calculate the multiplication of A and B, we expect that the answer should have a size of 2 by 2. This is very important. So before we even perform the multiplication operation, we must be able to determine accurately the size of the matrix. So that will help us confirm if our multiplication operation was done correctly or not. That explains rule 3. Now for rule 2, let's perform the multiplication operation. So performing AB, matrix A is -1, 2, 0, 3, 1, and -2. And matrix B is 2, 1, -3, 0, -1, and 4. That will be equal to Now let's check rule 2. Rule 2 says the multiplication operation is done with the rows of the first matrix and the columns of the second matrix. The rows of the first matrix and the columns of the second matrix, which means the multiplication operation is done with just only these two things in mind. So how do we apply this? Let's go to the first row. So we have this. We multiply it with the first column. So we have, let's go to the first element here, which is minus 1. We multiply this minus 1 with this 2. So we have minus 1 times 2. Minus 1 multiplied by 2 plus, we go to the second element here, which is 2. We multiply it with 1. So we have 2 times 1. 2 multiplied by 1 plus, we go to the third element, 0. We multiply it with minus 3. So we have 0 times minus 3. 0 times minus 3. And we are done with the first row and the first column. Next, we go again the first row, but this time around, it's going to be with the second column. So since we are dealing with the second column, we leave a space and start here. So we have the first element, which is minus 1. Now we multiply it with 0. So we have minus 1 times 0. Minus 1 times 0 plus, we go to the second element, 2 here. We multiply it with minus 1. So we have 2 multiplied by minus 1 plus, we go to the third element, 0. We multiply it with 4. So 0 multiplied by 4. And we are done with the first row. Next, we move on to the second row. We multiply it with the first column. So the second row multiplied with the first column, we have 3. We multiply it with 2. So we have 3 times 2. Plus, we have to the second element, 1 multiply with 1. So we have 1 times 1. Plus, we move on to the third element, which is minus 2. We multiply it with minus 3. So we have minus 2 times minus 3. We're done with the second row and first column. So we go again the second row, but this time around is going to be with the second column. So second row multiplied by second column. So we leave a space. So we have 3, the first element, multiplied by the first element here, which is 3 times 0. So 3 times 0 plus, we go to the second element, 1 multiply with minus 1. So we have 1 times minus 1 plus, and last element, we have minus 2 multiply with 4. So minus 2 times 4. And that completes the multiplication operation. So like the rule 2 says, the multiplication operation is done, the rows of the first matrix, and the columns of the second matrix. That's the way a multiplication operation is done. So now let's simplify what we have. So that's equal to minus 1 times 2, that's minus 2, plus 2 times 1, that's 2, plus 0 times minus 3, that's 0. Next, we go to the second column, still on the first row. Here, minus 1 times 0, that will give us 0, plus 2 times minus 1, that will give us minus 2, plus 0 times 4, that will give us 0. And to the second row, we have 3 times 2, that will give us 6, plus 1 times 1, that will give us 1, plus minus 2 times minus 3, that will give us 6. Next, we have here 3 times 0, that's 0, plus 1 times minus 1, that's minus 1. And lastly, plus minus 2 times minus 4. Mistake, here is supposed to be 4 and not minus 4. So we have 4. So minus 2 times 4, that's minus 8. Close the parenthesis. Simplifying, we have equal to minus 2 plus 2, that's 0. 0 plus 0, that's also 0. 0 plus minus 2, that's minus 2. Minus 2 plus 0, that's minus 2. To the second row, we have 6 plus 1, that's 7. 7 plus 6, that's 13. And lastly, 0 plus minus 1, that's minus 1. Minus 1 plus minus 8, that's minus 9. So the product matrix, that is the answer, is 0, minus 2, 13, and minus 9. As we've expected, we can see that the answer is 2 by 2. So we have 2 rows and 2 columns. If you are confused, you may rewind back and listen to our explanation again. Let's calculate the second question, which is BA, the matrix B multiplied by the matrix A. So question 2, BA equals, matrix B is 2, 1, minus 3, 0, minus 1, 4. Multiplied by minus 1, 2, 0, 3, 1, minus 2. We can see that the size of the first matrix here is 3 by 2. So we have 3 rows, 2 columns. And the size of the second matrix is 2 by 3. We have 2 rows, 3 columns. So since the first matrix column, which is 2, and the second matrix row, which is 2, are the same, we can perform the multiplication operation. And we expect that our answer should be 3 by 3. Let's calculate and see. So BA should be equal to, we'll go to the first row, we'll multiply it with the first column. So let's go one by one. We have 2 multiplied with minus 1. So 2 times minus 1, that's minus 2, plus 0 times 3. 0 times 3, that's 0. Next, still on the first row, but now we multiply with the second column. So the first row multiply with the second column. We have the first element, 2 times 2, that's 4, plus the second element, 0 times minus 1, that's 0. We multiply the first row again with the third column. So the first row multiply with the third column. We have the first element, 2, multiply with 0. So 2 times 0, that's 0, plus the second element, 0 times minus 2. 0 times minus 2, that's also 0. Next, we go to the second row. We multiply it with the first column. The second row multiply with the first column. We have the first element, 1 times minus 1. That's minus 1, plus the second element, minus 1 times 3. That's minus 3. Next, the second row again, but this time around with the second column. The second row multiply with the second column. So we have the first element, 1 times 2, 2, plus the second element, minus 1 and 1. So minus 1 times 1, that's minus 1. And lastly, the second row again, but this time around with the third column. So the second row multiplied by the third column. Take the first element, 1, multiply it with 0. So 1 times 0, that's 0, plus the second element, minus 1, times minus 2. So minus 1 times minus 2, that's 2. Lastly, we go to the last row and we multiply with the first column. So the last row multiply with the first column. So the first element, minus 3, we multiply it with minus 1. So minus 3 times minus 1, that's 3, plus the second element, which is 4, we multiply it with 3. So 4 times 3, that's 12. Next, we take the third row, we multiply it with the second column. The third row multiplied with the second column, we have minus 3 times 2. That will give us minus 6 plus the second element 4 times 1. So 4 times 1, that will give us 4. And lastly, we multiply the third row with the third column. So we have the first element, minus 3, multiplied with 0. That would give us 0, plus the second element, 4, multiplied with minus 2. That will give us minus 8. And that completes the multiplication. So let's simplify. That should be equal to minus 2 plus 0, that's minus 2. 4 plus 0, that's 4. 0 plus 0, that's 0. Minus 1 plus minus 3, that's minus 4. 2 plus minus 1, that's 1. 0 plus 2, that's 2. And the last row, 3 plus 12, that's 15. Minus 6 plus 4, that's minus 2. 0 plus minus 8, that's minus 8. And that completes the operation. As expected, we can see that the size of this matrix is 3 by 3. We have 3 rows and 3 columns. Hope you found this video helpful. If you did, please leave it a like and please subscribe to the channel. Thank you very much. See you in another video.